this is lesson 1.6. So some terminology to know. We briefly touched on adjacent in the past, but adjacent means next to, and more than that, it means sharing a side and a vertex, but not overlapping. So if I were to draw a little diagram, angle 1 here and angle 2 here would be considered adjacent because they both share this common side and they both have the same exact vertex. I could not say that angle 1, as I've now drawn in blue, is adjacent to the whole angle, even though they share a side and they share a vertex, they overlap each other. So that would not be considered adjacent. Complementary and supplementary are words you should have learned a very long time ago. They refer to a relationship between angles. So complementary angles are angles that add to 90 degrees. And then supplementary angles are angles that add to 180 degrees. There's a few tips I have for remembering which is which. Complementary is alphabetically before supplementary, so 90 comes before 180. That's the most basic one. For the word complementary, if you take the C and drag it down, that's 90. And if I turn the S into an 8, that's more 180. So that's the closest I can get for visual representations of which one is 90 and which one is 180. Example 1. In the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So the complementary and the supplementary do not have to be adjacent. It is possible for them to be adjacent, but it is not a requirement. It's just about the values adding to specific numbers. So if I'm looking for a pair of complementary angles, I'm looking for a pair of angles that adds to 90 degrees. So 37 plus 53 is 90 degrees, so those two angles would be complementary. So that would be angle CAB. Remember naming angles, we have to go in order, vertex in the middle. And then the other one I can call RST, but also if you remember, if there's only one angle at the vertex, we can actually shorten that up and just call it angle S. As for supplementary angles, now we're looking for a pair that adds to 180. So 127 plus 53 is 180 degrees. So I can call that angle CAD and angle S. As for adjacent, we know that they have to be touching. So this angle is out already because it's not touching any other angles. I do see two angles here next to each other. Both of them have vertex A, and between them is side AC. So that would be angle CAD. Oops, let's try writing that correctly. And angle CAB. In example 2, the measure of the supplement of an angle is 40 more than 2 times the measure of the complement of the angle. So we have an angle, right? Let's figure out how to write this. We have an angle, it's X. The complement of the angle, let's make it equals, is Y. And we know that X plus Y equals 90, because complementary angles add to 90. They're comparing the supplement to the complement, and that's why I chose the complement to be my singular variable, because now my supplement is 40 more than 2 times that. So 40 more than 2 times this. So 2y plus 40. So now the angle and its supplement equals 180. And what we have is a system of equations. We could solve this either using substitution or elimination. I'm going to use elimination. So I'm going to move the 40 over. So it's x plus 2y equals 140. And now I have my two equations. Both of them have a plain x in them. So I want the x's to cancel out, which means I'm going to multiply this one by negative 1. So if it's negative x minus y equals negative 90, we're going to multiply everything in these parentheses by the negative 1. And now I'm going to line up my other equation, x plus 2y equals 140. Combining them, as we do in elimination, negative x plus x cancels. Negative y plus 2y is y, and negative 90 plus 140 is 50. So we've now found that 50 degrees is y. We do still want to find the measure of the original angle, which was x. So I'm going to go back to one of my original equations. So x plus 50 equals 90. So my original angle is really 40 degrees. All right, this is try 2. Pause if you'd like. Answers are posted online. Now we have a linear pair, which pair means 2. So it's 2 adjacent angles that form a straight line. So notice that the side that they don't share, this is the side they do share, the side they don't share, if I were to draw it out, made one single straight line together, right? No interruption in that line. The other type of angle relationship is vertical angles. And this is also going to be a pair, and it's two angles whose sides form two pairs of opposite rays. So essentially, it's the angles across from each other when lines intersect. So when these two lines fully intersect at this singular vertex, angle 2 is opposite angle 4. They are vertical to each other. Angle 1 is opposite angle 3. And you could always check if angles are vertical by taking the two sides of one. So here's the sides of number 1. So if I take the side of number 1 and keep going, and then I take the other side of number 1 and keep going, it did in fact form the angle of angle 3. So for example 3, let's make this a little bigger. Let's find a pair, a linear pair, and let's find a pair of vertical angles. The linear pair is probably the easiest because all I have to do is draw a single straight line in this picture and then split it into the two different angles that I want to refer to. So let's say I took this line here. I now have 1, 2, 3, 4, 5 different rays I could choose to use to split it. Let's even say I use this one. So the angle formed here by combining 1 and 2, and the angle formed here by combining 3 and 4 would be a linear pair. So let's name them, because I can't call it 1 and 2, I can't call it 3 and 4, I have to give them names with the 3 letters. So that would be angle AHC, and angle EHC. As for our vertical angles, I can draw two completely intersecting lines. So the only line I wouldn't choose is DH, because it cannot continue past it, so I'm not going to use that as one of my intersecting lines. So let's say I took this line here and this line here. So I can see that 6 and 2 are opposite each other, formed by these intersecting lines. So I can say angle 6 and angle 2. If you want to name them by the letters instead, that is fine, but any chance I get to name an angle by a number or a single letter, I will take it. Vertical angles and linear pairs are actually incredibly important. We're going to use them the entire school year. And just like I had mentioned proofs, they are going to be critical in some of the proofs that we complete. So there are theorems and postulates about our linear pairs and our vertical angles that we're going to apply now. The linear pair postulate says that linear pairs are supplementary. And that makes sense because they form a straight line, which means straight lines are 180 degrees, supplementary is 180 degrees. The vertical angle theorem says that vertical angles are congruent. So I can automatically set angles across from each other equal to each other. In example 4, we want to find the values of the variables. So our first step here is going to be identifying where the angles are that have the same variable, if there are any. So I see that I have a term x here, and I have the term x here. These are vertical angles. They are across from each other when the lines intersect. So that tells me I'm actually going to be setting these equal to each other. So I could do 5x minus 47 equals 3x plus 17. Take away the 3x, add the 47, and then we could divide by 2. And then the same is going to go for the y's. I have a y here and a y here. Those are vertical to each other. Notice I'm using different curves in the corners because it's a different pair of congruent angles. So I'm going to have 2y plus 9 equals 3y minus 20. Subtract 2y and add 20. And now I've solved for y. In try 4, if you are going to pause and try it, please note that the x's are no longer across from each other. The y's are no longer across from each other. They are now next to each other. So you are not dealing with vertical angles in this problem. You are dealing with linear pairs. In example 5, most of our angles have 2 variables in them. So there's not going to be any one easy way to do this. But we do have many options. So I'm going to start by taking a pair of vertical angles and setting them equal. So I'm going to say 5x plus 5y minus 1 equals 3x plus 6y. And generally speaking, I like to have all my variables together on one side, numbers on the other. So if I took away 3x, if I took away 6y, and I moved the 1 over, I get 2x minus y equals 1. And I'm going to do the same thing for the other pair of vertical angles. I'm going to set them equal. So we have x plus 8y plus 2 equals 8x plus 4y plus 3. So I'm going to subtract 8x. I'm going to subtract 4y. And I'm going to add, subtract the 2. So here's my 2 equations. It's going to be more difficult to make the x's cancel out this time because it's a negative 7 and a 2. There's nothing I can multiply the 2 by to easily make it a negative 7, or a positive 7 really. But then I have negative 1y and positive 4y, and they'll cancel if I can get this to become a negative 4y, which means all I have to do is multiply it by 4. So let's do that. We're going to have 8x minus 4y. Oops, that's a terrible 4. Equals 4. Don't forget, it has to go to everything in the parentheses. And I'm going to rewrite my other equation. So 8x minus 7x is x. My y's cancel. And 4 plus 1 is 5. So that's it. We've already solved for x. And just like before, I'm going to take that and go back to one of my original equations. So let's say we go back to the 2x minus y equals 1. So 2x minus y equals 1. That's 2 times 5 minus y equals 1. 10 minus y equals 1. Subtract the 10. Negative y is negative 9. So y is positive 9. If you'd like to write your answers as ordered pairs, that's fine. Just make sure you put x, comma, y. But also, it's just as fine to leave it as x equals and y equals. All right, here's try 5. It's very similar to what we just did. Pause if you would like to try it. The answer is posted online. We have a few more theorems to talk about that could be useful if you remember them, but they're not incredibly important to memorize. One, actually no, I take that back. This one is incredibly important to memorize. We will be using it quite a bit. The next one's not so much. So the right angle congruence theorem. This will be used in proofs. It just says that all right angles are congruent. So as long as you know that these are both right angles, we can say that they are automatically congruent to each other. The other two, these are the ones that we don't really need to rely on as much, the congruent supplements theorem and the congruent complements theorem. So the congruent supplements theorem just says that if two different angles are both supplementary to the same angle, that makes those two angles congruent to each other. And that makes sense, because let's say we knew angle 1 was 20 degrees, and 1 and 2 are supplementary, making this 160 degrees. If I also know 2 and 3 are supplementary, that would have to make 3 20 degrees, automatically making those congruent. And then the same thing works for the congruent complements theorem. If you know that two angles are both complementary to the same angle, that means they have to be congruent to each other. And that is section 1.6.